This is Algebra 1, lesson 6.5, graphing a linear inequality in two variables. It's just like graphing an equation, except you have to make a solid or dashed line based on what the symbol says, and then you have to shade one way. You have to shade what's called a half plane, beginning on page 360 in the textbook. A linear inequality, in x and y, is an inequality that can be written as ax plus by. This is just standard form if you notice it. Ax plus by equals c. It's just saying less than or equal to, greater than or greater than or equal to. That's all it's saying. It's a big long definition that just shows you standard form with the four different inequality symbols in it. That's what a linear inequality is. Again, we know four different forms of an equation, which also means we know four different, I'm saying four, excuse me. We know three different forms of an equation, which means we also know three different forms of an inequality. We know slope-intercept form, we know point-slope form, and we know standard form, which is what's shown here. A solution of a linear inequality is any ordered pair. Remember, an ordered pair is both an x and a y value. That gives a true statement when you plug it in or when you sub it in. So solution, you just need to know to pair solution with true. Solution gives you a true statement. Something that is not a solution would give you a false statement. A graph of a linear inequality in two variables is the graph of the solutions of the inequality. Okay, so what that is, it's just like graphing a line, just like graphing the linear equations we learned how to do, except again, it's going to have either a solid or dashed line, just like a line, but you're going to shade one side or the other based on truth value of one point, based on if something is a solution or not. And then a half plane. A half plane is a region on either side of a boundary line. The easiest way for me to explain what a half plane is to draw one and show you. When you graph a normal line, you're simply going to have a line with arrows pointing in both directions. When you graph an inequality, the line may or may not be a dashed line. It'll be determined whether it says or equal to or not. Okay? So now all of the numbers in existence according to this plane are separated by that blue line going through the middle right there. So a half plane is going to represent everything this direction or everything that direction. So typically when you're talking about half planes, you're talking about everything as I got it pointed to the left or everything pointed to the right. That's what it means by half plane. Example number one is simply checking solutions. This ought to be extremely easy for you. Plug the numbers in, see if you get a true statement or not. 0, 0, again, that's the one we're almost always going to use unless it falls directly on the line. Instead of 8 times x, you got 8 times 0. Minus, instead of 4 times y, 4 times 0. Again, we know anything times 0 is 0. So that gives you 0, which is greater than or equal to 3. That is not a solution. That's going to happen often with these problems. It's either going to come out to be true or not. True or false, solution or not. 0, 0, the easiest thing to plug in. The other one, 1 and negative 1, when you plug it in, 8 times 1, we know that's going to give us 8. Negative 4 times negative 1 is going to give us positive 4. So 8 plus 4 is 12. 12 is greater than or equal to 3. Therefore, 1 negative 1 is a solution. So that's how you check to see if it's a solution or not. So real quick, let's check. We'll just do this one. On the back, 4x plus 5y is less than or equal to 12. Plug in negative 3, 5 and see if it gives you a true statement or not. Take 30 seconds. Again, 4x plus 5y is less than or equal to 12. In place of x, we're going to plug in negative 3. In place of y, we're going to plug in 5. So 4 times negative 3, this gives us negative 12. 5 times 5 is going to give us positive 25. Is that less than or equal to 12? We have to determine that based on putting those two numbers together. Negative 12 and 25 gives us 13. Is that less than or equal to 12 is the statement you got to ask yourself. Or question, no. The big mouth in this case is eating the 12, which is a smaller number than 13. So this would be no, not a solution. Graphing a linear inequality is as simple as graphing the corresponding equation. Graph it just like it were an equation. Again, we can graph in 3 different forms. We can graph in slope-intercept form, y equals mx plus b, by beginning at b and moving with our slope. We can graph in standard form by using the x and y intercepts like we did in the bell work. Or we can graph in point slope form, but we didn't do a whole lot of working with it in point slope form, but you can do it that way as well. The first difference with an inequality is you need to use a dashed line if it just says greater than or it just says less than. You need to use a solid line if it also includes or equal to. That's the first difference, solid or dashed lines. The second difference is you need to pick one point. So the line drawn in step 1 separates it into 2 half planes. Test a point in one of the half planes to determine if it's true or not, or to determine a solution of the inequality. Again, the easiest point to use is 0, 0. The only time you can't use 0, 0 is if the line falls directly through the origin, which sometimes it does. And I'll show you how to do that when we get to that one. Step number 3 says, if the test point is a solution, if you get a true statement, shade that way. If it's not a solution, if you get something that's false, shade the other way. This is graphing a linear inequality. Graph x is greater than 3. So the corresponding equation, x equals 3, is a vertical line. You have to use a dashed line. We know that this right here is our x-axis. We use a dashed line where it crosses through at 3. Remember, anytime you only have one variable, you're going to have either a straight up vertical line or a straight across horizontal line. So that's the first difference. If it were just an equation, we would draw a straight line through it, we would be done. It is an inequality, and it doesn't say or equal to. So the first difference, dashed line. The second difference, we got to shade either everything on the left or everything on the right. So what we want to do is we want to pick a point that's not on it. 0, 0 is always the best point to use unless you can't, because we can easily plug in the number 0, 0. So in place of this, 0 is greater than 3. You got to test and see, is that true or not? 0 is not greater than 3. 3 is the bigger number. So what that means is everything over here is wrong. Don't shade that way. Shade opposite. Everything on that side is right. And that's how you need to shade it, to where you don't make a big old huge mess. Shade everything on the right side of the line. In the bubble, again, it says you can test any point that is not on the line. The origin is most often used because it's easy to multiply and sub in 0, 0. Okay, the checkpoint tells us to sketch the graph of the inequality. Y is less than or equal to negative 4, and x is less than 2. Again, only one variable. Y is less than or equal to negative 4. This is your y-axis, so it's crossing through there. Less than or equal to means you're getting a solid line. So you're going to have one that looks like that. That's the first difference, solid or dashed. The second difference, do you shade everything above it or everything below it? Plug in 0, 0 to determine it. 0 goes here. 0 less than or equal to negative 4. True or not true? True or false? In this case, 0 is a bigger number than negative 4. It is not true, so you shade away from 0, 0, everything that direction. For example, number 3, it says sketch 2x plus 3y is less than 6. The first thing you're going to do um, is create slope-intercept form. Again, you can graph out of standard form by using the intercepts. Totally fine. But if you can't, make slope-intercept form. That's also totally fine. Move negative 2x over it, it becomes negative 2x. It's just like we did on the bell work. Subtract 2x on both sides, it becomes negative 2x. Then divide by 3. That gives you y equals negative 2 over 3x plus 2. Y equals mx plus b. So we have a place to begin at. B's value is 2. So B's value is positive 2 right there. That's where you begin. M's value is negative 2 over 3. That means go down 2 and to the right 3 times. So down 1, 2, to the right 1, 2, 3. There is your second point. If it were just an equation, we would just draw a line through them and just be done. But it's not. It's an inequality. We have to determine solid line or dashed line. Nobody ever messes that up. Which one do we do? Dashed line. It just says less than. It does not say or equal to. So through those 2 points, you're drawing a dashed line just like that. Some people call it a dashed line. Other people refer to it as a broken line. It means the same thing. So if you see that term broken, that's what it means. Dashed line. Then you have to determine, does 0, 0 make it a true statement or not? It does not pass through 0, 0. So let's test 0, 0. We'll plug it right there. 2 times 0 plus 3 times 0 is less than 6. 0 plus 0 is less than 6. Is that true or false? That is the big mouth eating a big number. Yes. So you shade towards 0, 0 for that case.